In previous lessons, we have looked at how, when we're modeling surfaces in our PHPP areas worksheet, we are asked by the PHPP to designate a group type or a type to our various surfaces. So we talked about how we use the group type numbering system to designate whether something is a floor or a wall or a roof, etc. And we talked briefly about why we do that. One of the main reasons being that we want to be able to tell PHPP these surfaces are above grade or exposed to the outdoor ambient air. And then these other surfaces are exposed to something else, whether that's a garage or a sunroom, or, as we'll talk about in this lesson in the next section, the ground. So we've talked about how in our example project here, we have a single ground contact surface. We have a floor surface, which is sitting right on the ground. And so we tagged it as a special type of surface, group type number 10, which tells PHPP, oh, this is a ground contact surface. And so calculate heat flow accordingly. So in this series, what we'd like to do is take a closer look at questions of how we model ground contact surfaces and how the PHPP is going to take into account the buffering impact of the ground itself. So I am here in my PHPP. I've got my EDS PHPP model opened up here, and if you've been following along, hopefully you have a PHPP that looks something like this, where you've got all the various surfaces modeled. We've got the TFA modeled, and if I was to scroll down a little bit in my scene here, notice we've got all of our thermal bridges modeled here as well. So we've got an awful lot completed in our PHPP here, and we, as I said, can now move on and look into some other areas of the PHPP. And as I just said, the first of those is going to be the ground. So how are we going to tell PHPP what kind of reduction factor to apply to those ground contact surfaces? Well, in PHPP, the way we're going to do that is we're going to apply, or going to fill in a whole set of information in the ground worksheet. So here in the PHPP, I'm in the areas worksheet currently, but if I was to shift over to the ground worksheet, we're going to see a whole bunch of places where we're going to be asked to input additional information to the PHPP about the ground condition. What type of contact does your building have with the ground? Is it a slab on grade? Is it a below grade heated basement? Is it a crawl space, etc., etc.? So let's take a look at that. I'm going to shift over to the ground worksheet now, and we'll sort of zoom out and take a look, and then of course we'll dive into all the various bits and pieces. So I'm in the areas worksheet currently. We're all done here. I'm going to shift over to a new worksheet, and I'm going to go and just click on this worksheet here called the labeled ground. So here's our ground worksheet. And again, before we take a look at any details, let me just zoom out a little bit so that we can kind of get an overall picture of what the heck is happening here. So we've got sort of three sections here to this worksheet. We've got an upper section here, and remember the yellow cells are where we input information. So a lot of this worksheet is about calculation and reporting. It's not a ton of places here we have to put a lot of information in, but we have one upper section here that we'll take a look at. It's going to be general information about the ground. We then have a middle section here, which is asking us to describe our particular ground contact surface. Is it a slab on grade? Is it a crawl space? Is it a heated basement? How tall is the basement wall? The U value of the wall, U value of the floor, etc., etc. So there's going to be a whole bunch of parameters we're going to be asked to input there. And then we have this lower section, and the lower section here is going to be used by the PHPP to calculate ground temperatures for every month. And so we will look in a minute, but if we look closely, what we'll see is that there are 12 columns, one for each month. And so what the PHPP is going to do is it's going to take all of this information up here that we're going to input, and it's going to calculate a series of ground temperatures for the model. Using those ground temperatures, it's going to create a derating factor, an F sub T, a temperature correction factor. And that temperature correction factor is going to get applied to all of the ground contact surfaces in our model. So we have to describe how our building touches the ground, and then PHPP is going to go off and do a whole bunch of work. Okay, so let's dive right in and let's start filling in the information here. So I'm going to zoom in on the upper left corner here, and let's start taking a look at what types of information, we are asked to input. All right, so I'm zoomed in here, and for the time being, let's just look at this upper panel. Don't worry about this whole lower section. Let's just restrict ourselves to this upper panel here. We'll just sort of go through it one piece at a time. So remember, the yellow cells are where we are asked to input some information. And if your PHPP is like mine, you should have some default values already in for a few bits of information. So the very first thing we have to do is we have to describe the ground, the soil. So for your project, what type of resistance, R per inch, does the soil have? And what's the heat capacity of the soil in your location? Now, those are some weird values. You might not know those values. So, for instance, if we were to hover my mouse over the R per inch here, you will see that we get a little tooltip that comes up and it says, well, depending on the type of soil, if it's, silt or clay, if it's dry sand, wet sand, moist clay, if it's solid bedrock, building in Manhattan or something, you might have different values for the R per inch. Now, a standard R per inch, a sort of medium R per inch, would be 0.07. And for the most part, you can leave that. That should be the default value, which is already input there. And you should be able to just leave that in for most cases. Now, if you have a detailed geotechnical report for your project and you have a resistivity or a resistance value for the ground, go ahead and put that in. That's great. The more accuracy, the better. But if you don't have any information and if you want to just use a standard default value, then an R per inch of 0.07 would be a reasonable value to input there for the thermal resistivity of the ground. Now, similarly, we are asked to input the heat capacity of the soil. So again, it's going to kind of vary depending on the soil that you're working on, depending on the soil under your building. Notice here we get a range of typical values for the PHPP. And again, we have a default value of 30 BTUs per cubic foot degree Fahrenheit input here. That would be a pretty good medium value. But of course, if you do have a detailed geotechnical report, if you've actually gone out and done an assessment of the soil for your particular project, feel free to input those detailed values there. All right, so for the most part, we can leave those set to the default, so that's great. Now over here on the right-hand side, this is all just reporting data. Notice there's no yellow cells for input. We're just getting a bunch of information about our climate here, so that's fine. The next section that we are asked to input is this bit here about the building data. So let's take a look at this one. So the building data, we're asked to input quite a few pieces of information here. So let's again go through this one bit at a time. So first of all, we have to input the area of our ground contact surface. So we have a floor surface that's sitting on the ground. We have to input the area of that ground contact surface. We also have to input the perimeter length. So we have to measure the perimeter, the outside edge of our floor surface, and enter that here as a value. Thirdly, we have to input the R value of the floor slab. So we have to input the total resistance of that floor slab element. And then lastly, we have to input the thermal bridge of the floor slab here. But notice it's not just the psi value. We have to take the psi value and we have to multiply it by the length. So for each of those edges, for each of those slab edges, for each of the footing areas on the outside, we have to take the psi value of that slab edge and multiply it by its length. So it's not just the psi value. Notice the units over here, BTUs per hour degree Fahrenheit. You have to multiply this by the length of that perimeter. Okay, so 4 pieces of information. We just have to input them one at a time. So let's go through and take a look at what those will be. Let me open up my example files folder here. So again, I've got my example files that I downloaded from the Canvas website. And let's just open up our drawing set here so we can take a look and just remember what it is that we are building. So we've got our little home here, and let me scroll down to the building section because I think we can get most of the information there that we need. And of course, when we're asked to input here, so go back to our PHPP for a second, the area of the ground floor slab or basement ceiling. So in our case, this is a ground floor slab. We have a slab on grade. And so I need to input the area of this surface right here. And when inputting the area, of course, in the PHPP, we're going to use the exterior dimensions convention, just like before. And so I just need to find the exterior dimensions of this surface and input it here in the PHPP. Well, if I go back to my floor plans, let me go back to the floor plans here. Remember, just as before, we can just measure from, we can measure the length, the length and the width of the building, so 41 foot 9 and 21 foot 9. So I can just use that to calculate the area here in this section. So let me go back to my PHPP, and I'll come in here to the area of the ground floor slab or the basement ceiling, and I'll just type equals 41.75, 41 foot 9, times, times 21.75, 21 foot 9, and hit enter. And then notice that Excel goes off and calculates the total area of that ground contact surface. So we just put in the area of that surface which touches the ground. Okay. All right, next, the perimeter length. So the perimeter length here, and if I hover my mouse over, notice we get a tooltip here. It says, coverage of the floor slab or the basement ceiling, depending on the type of foundation, only the free edges are considered into the calculation. What does that mean, only the free edges? Well, if we go back to our drawing here, what it's asking for, so what this input is asking for is the length of the perimeter around the outside of the building. But what's that qualifier about free edges? Well, what it's saying is the PHPP, I only want you to input an edge if it is exposed to the outdoor air. So what it's telling us to input are exposed edges only. What would be a case where we would have an edge that's not exposed? Well, consider if I was to draw, consider a row house. So let's say if I was to draw a floor plan of various row houses, right? If we have a whole bunch of, call this a plan view of row houses, and if this is our house right here, right, this is our building that we're working on, well, we might have a floor which is the entire floor of the building, but only this front edge here is exposed on the front, and then we've got a sort of back edge which is exposed on the back, but the two party walls are not exposed. It's a weird drawing. I don't know why it keeps defaulting to dashed, but anyway, so what this is asking us is to only include the exposed edges. Don't include any edges up against a neighbor, up against a garage, something like that. Only include edges which are exposed to the outdoor air. Okay, well, in our case, all 4 of our edges are exposed to the outdoor air. So I have an edge here, which is 41 foot 9, that's exposed. I have an edge here, which is 41 foot 9, which is exposed. I have an edge here, which is 21 foot 9, which is exposed, and an edge here, which is 21 foot 9, which is exposed. So I just need to add up that total length. All right, so let me go back to my PHPP, and I'll do it with an equation here again. So I'll come in here to perimeter length, and I'll say equals 2 times 41 foot 9 plus 2 times 21 foot 9. And of course, entering those as decimal values. So 41 foot 9 is 41.75 feet, and 21 foot 9 is 21.75 feet. And so I can just enter that formula there and hit enter, and notice I get a total value of 127 feet for the exposed perimeter of the building. Alrighty, so the next piece here, the R value of the basement floor slab. So 2 ways we can enter this R value here. We could just enter the value, R25, or whatever the number was, or because we've already calculated the R value, and because I would want this value to change if I changed the R value of the ground contact surface, I can link this cell back to another location. So for instance, I'm going to go over to my R values worksheet here for a second. Let me shift worksheets and go to my R values worksheet. If we remember that we built our floor assembly here in the very first R value constructor, and we got a total R value of 24.97. Well, as I said, I could just copy and paste this number, but that wouldn't be very good. If I came in here and I added more insulation a few months from now, I would want this value to be linked to the ground worksheet. So I can do that. Let me go back to my ground worksheet. So I'm going to shift back to the ground worksheet. I'm going to come up to the R value of the floor slab, and I'm going to go over to the cell, and I'm going to type equals. And then I'm going to come down here and go to the R values worksheet, and I'm simply going to click on the cell with the total R value that I want this reference to inherit. And notice here I get the formula R values exclamation point Q28. And so if I hit enter, notice that that number 25 comes through. If I increase the detail there, you'll notice that the number is actually 24.969, whatever. And so if I come back to my R values worksheet a month from now, and I increase the thickness of the insulation to 10 inches, notice my R value jumps to 40. Go back to the ground worksheet, notice this inherits that R value. So because it's Excel, we can use this type of linking functionality. Let me undo that before I forget. I'm going to undo that, put it back to 6 inches. We can use this linking functionality to establish these links throughout our PHPP. Now, the one warning that I would give you about that is just make it obvious that that's a link. So what I like to do is when I link something like that, I like to come up here, come into my home view, and I might give it a different styling. So maybe I'll do something like this, and I'll give it like a grayish background. Maybe I'll italicize the numbers so that it's really clear to me 6 months from now, oh, hey, that's a linked value. Don't just start typing numbers in there. Remember, you linked this one on purpose to some other worksheet, some other cell. You could give yourself a comment. I could right click and I could add a comment here. Of course, I'd have to unprotect the worksheet to do that. You could also do that. You could leave little breadcrumbs for yourself to sort of keep track of what you have been doing. All right, so that's fine. So so that's cool. We can do that. We can make those links, and now that information is sort of being propagated through into our ground worksheet here. All right, the last input that we want to do in this lesson is we need to input our thermal bridges for the floor slab or the basement ceiling. And remember, the thermal bridge is times the length. Well, I have the thermal bridge for the floor slab edge. So if I go back to my areas worksheet here, and I scroll down to the bottom. Let me zoom in here on the thermal bridges section. Remember, we have this footing detail. So we have this detail for our footing. So what I want to do is I want to take this number and I want to use that to get a calculated value here. So I'll start by just doing that. I'll start by making a reference. I'll say equals on my areas worksheet. I'll click on areas X148 and I'll calculate that through. I'll bring that through. But again, this is not just the psi value, it's the psi value times the length. So what I need to do is come in here and I need to modify this. I need to say it's the psi value multiplied by, so using the times operator, this perimeter length value, because we use the same psi value for all of those edges, and I could just put that in and type enter, and I get this negative 4.5 value. Okay. And again, because this is linked, maybe what I want to do is I want to come in here and I want to give it some styling, and I want to make it really obvious that this is coming from somewhere else. This is a calculated field. I don't want to just start typing numbers in there. This is being determined by something else, some other place. I could leave a comment for myself or whatever. Same as with the R value worksheet there. Okay, so we've now completed the basic data entry. So no matter what type of ground contact surface I have, whether it's a slab on grade, whether it's a heated basement, whether it's an unheated basement, a crawl space, whatever, I have to input this information. So I have to input all of this information no matter what. When we come back in the next video, we will take a look at entering the specific information about the specific type of ground contact surface that we have for our example here, a slab on grade floor slab. So we'll come back in the next video and we'll take a look at what it takes to model that type of ground contact surface.